Today we're going to do, yesterday we did linear equations, now today we're going to do linear inequalities. So we're going to do a few extra letters, but it means something kind of totally different. Not totally different, but something a little bit different. So our learning target is I can graph and write linear inequalities. So it means it's not equal necessarily. Now we do have some that are equal to, but if we got to throw greater than or less than in there. So now this does say recall inequalities from Unit 2. That was Unit 2 of Algebra 1, so that's why that's there. We kind of grabbed some of these notes from the Algebra 1 teachers, and I forgot to cut that part out. So if you see that, don't fret too much. It's like, what are you talking about, Unit 2? Because our Unit 2 is totally different than that. But it says, show all the solutions for the inequality x is greater than 4. Well, the problem is, if I said, give me some solutions, like what would be a number larger than 4? 5, 6, 7, we could say 5.5, 4.5, 4.1. We could start saying them, but how many are there? How many solutions? How many numbers are larger than 4? Infinite, right? So inequality, infinite solutions. There's too many. We couldn't list them all. But that's why we need to graph them. That's why we have to graph them. So a quick way to graph them, over here I got a number line. One variable, one axis. Okay, it says in the inequality above, if I can talk, how many variables does the inequality have? Well, it has x, so all I need is an x-axis to go on. Okay, so this one I'm going to go to 4. I want to plot a larger than that. Well, if here's 5, here's 6. I know those are going to be that work, and I know that 5.5 in the middle, and well, anything in between 5 and 6 will work. What's the first number that doesn't work? If I'm going this direction, like 4.5 works, 4.1 works. What's the first number that doesn't work? 3.9. It's very close. Yeah, 4 itself. Yeah, because 4 itself is not greater than 4. So the first number that doesn't work, we put an open circle for to say this is not, but everything up to this is. So my graph is going to be starting anything just the right of 4 and on up to the right. So we can't list them all, but we can graph them. We can give a picture representation. Is 100 in there? Yeah, 100 is just way down the graph, but 100 would be a solution, and 1,000, and so on. So the linear inequalities we're going to do today, it's an equation with two variables. So we're going to have an x and a y, but we're going to replace equal sign with an inequality symbol. So we're going to take out the equation. Like yesterday, everything was equals, and we graphed everything with equals. Well, the good news is we can do the same thing. Hey, it's just we got to do an extra step. We got to do one step. So it says, note that the process is almost exactly graphing lines except two things. So we want to make sure that our equation is in slope-intercept form. And that makes life easier. If it's in slope-intercept form, if you don't have it in slope-intercept form, it's still possible, but it's more work. If you just the first put in slope-intercept form, everything else is easier. It's quicker. And plot the points just a regular line. Don't get to, well, if I multiply or divide by a negative number, what do I got to do? Anytime you multiply or divide by a negative, you got to switch your symbol, so you don't forget to switch. So if it was less than, now it becomes greater than. If it was less than or equal to, now it's greater than or equal to. So it's going to switch over. And then you must make sure that your line is solid if it has an equal to. So if it's less than or equal to or greater than or equal to, you got to make it solid. So it's a solid line like yesterday. But if it's not greater than or equal to or less than or equal to. So basically if there's no equal to, if it just says less than or greater than, then you want to make it dotted or dashed. However you want to say it. I think it's almost easier to do more dash than there's a dotted line, but they can sound the same. And then this line that we're graphing, a solid or dotted line, that separates the solutions from the non-solutions. So that's kind of the border between solutions and non-solutions. Now we do need to make sure the side has the solutions, we need to shade it. So you must shade of your sides, and that shaded side represents all the solutions. So the shaded side represents all the solutions. So that's kind of our extra steps. Our extra steps there is we do solid or dotted based on if it's equal or not, and then we got shade on one of the sides. That's the extra stuff we do above what we did yesterday. So to determine what side to shade on, this is where the slope-intercept form makes it easier. So we set up here, put in slope-intercept form. It's not that you have to, it's just if you do that, this is easy, or easier. Okay, so if the symbol is a greater than of any form, so if it's greater than or equal to or just greater than, then you're going to shade above. Hopefully that makes sense. You know, greater than is more, above means more, above, up. They all kind of mean the same, so that's nice. Because sometimes things mean the opposite of what you think they'd mean. But this one, that kind of makes sense. That greater than would be above. And then the less thans, whether it's less than or equal to or just less than, you're going to shade below. Let's try one here. Let's try one of these guys. So this is our inequality. Y is greater than or equal to 1/2 x plus 3. So your first is just pretend like it's like yesterday. Ignore the fact that it says greater than. Act like it says equal to and lock some points. So yesterday we had the plus 3. That means go up 3. Put a point. And then the slope of 1/2. From this point, I'm going to go up 1, right 2. 1, right 2. You can actually go down 1, left 2 to continue going the other direction. So if this was yesterday, I would just connect the dots and I'd be done. Now today it's inequality, so we're going to go a step further. Now, I got to decide, should I make that a solid line or a dotted dashed line? It is equals to, so it's greater than or equal to. So if it's equal to, it means I want to include these points. So these points are solutions. If it was just greater than, that means these points aren't solutions, but right next to them would be a solution. It's an open circle versus a closed circle. Well, this should be a closed or a solid dotted or a solid line. So a solid line. Equal to, and it makes all of them. And then step, we need a shade. Since this is slope-intercept form, I can use that trick. Greater than means shade above. So I need a shade above this line. If this was a roof of a house, the rain would come down on the side, so the rain would come this way. That's the top, this side. Okay, so I need a shade on this side. I'm not super worried how dark you shade that as long as it's shaded. You don't have to wear down half your pencil shading the side. And it has some questions here. So it says, is 0, 0 a solution? Now, one way would be to plug them in and see, but since I have a visual presentation of all the solutions, I just look at the graph. So 0, 0, is 0 in the shaded region or not? No, it's not. So that one's not a solution. About -2, 7. So -2, 7 is right there. It's in the middle of the shaded region, so that is a solution. And then I think 4, 5 is kind of a, let's see, 1, 2, 3, 4, 1, 2, 3, 4. It's right on the edge. So it's right on the edge. Is that a solution or not? Yeah, on this one, since it's equal to, since that's solid, that is a solution. If this was a dashed line, that would not be a solution, because it's on the edge, but it's not quite part of the solution set. Okay. So let's do this. Let's hold off on these for a second. I don't like the order here. So I want to practice these. So, and I messed up. I got the equations here, and on the next page is the graph. So if you want to, I'm going to flip this over, and I'm going to rewrite them. You know, I'll put them like that. If you want to rewrite them, there's your, that's what they're supposed to be. So try those out. Just practice graphing those two. So it's working. Okay, so yeah, the first class on this one, people had the wrong slope. Instead of having a negative 2/3, they had a positive 2/3 slope. And I said a few people on this one shaded on the wrong side. And this one, when it's steeper, I get where you're coming from. Like crosses here, goes up 1, 2, 3, 4, 5. It's a pretty steep slope, and it's hard to tell, well, what do you mean by above? Again, I always says the above, this is below. You know, it almost looks more like a left side and a right side than it does above and below. But this would be the left side. So if we want to go below, we got to go on this. This guy here, if we do it real fast, let's see, down 2/3. And this one is a dotted line or a dashed line because it's just greater than dash. And this says above, so it's shade above. Now, here, these answers, there's infinitely many correct. Just double check, make sure it's in the shaded area. So, like on the second one, you can pick points on the line, and that's fine. Like if I did 1, 4, that would be a solution. That's okay. Or anything over here. On this one, if I do, say, 3, 5, 3, 5 is not a solution because it's on the dashed line. So those would not count. So these you have to actually be above. Whereas this one, you can be on the line or below it. So I kind of let you grade these yourself. I don't. If you're still wondering, you can check later with me, and I'll look at it. Let's go back. I know we're bouncing around a lot. Let's go back to the word problem here, and we just make sure we cover a word problem. Make sure don't get overwhelmed by the word problems. I know sometimes we see a word problem, we think, nope, not doing it. Don't like word problems. But if you just give it a try, I think it can work. So a local baseball game, tickets for $5 and children are $3. We want to know what combinations of number of tickets do we need to sell so that we bring in more than $6,000. Okay, so first off, we kind of need to make a decision. What do we want to call X and what do we want to call Y? So maybe since they did adults first, let's call that X. So I want to say the X-axis represents the adult tickets, and the Y-axis represents the children's tickets. Okay, so X represents the number of adult tickets, and then Y represents the number of children's tickets. So if I took the number of adult tickets, well, they're $5 each. So I take how many tickets I sold times 5. That's how much money came in from the adults' tickets. So I take 5 times X. And then if a children's ticket's $3, then I'm going to take the number of children's tickets times 3. That would tell me how much money from the children's tickets. And if I add them together, that's the total amount of money. Right, so that would be the total amount. And I want that to be, and you got to be careful with the words here because this one says greater than, make greater than. It didn't say equal to. It said make greater than. Another way of saying greater than would be at least. So when you see the words at least, that's a different way of saying greater than. If it says at most, that's like saying less than. Now, when it says at most, you or including that, so maybe I should say that at most is less or equal to, and at least is equal to. But yeah, so this one is just greater than 6,000. So greater than $6,000. We just need to, well, in what form is it in? It's got 5x plus 3y greater than 6,000. Which form is that from yesterday? So yeah, if it's in standard form, to find the intercepts would be easier. Okay, so and we said this, the intercepts are good if this number is a multiple of both of these. So is 6,000 a multiple of 5? Yeah. Is it a multiple of 3? Yeah. So this one wouldn't be too bad to do, just leave it in standard form and find the intercepts. So the x-intercept and the y-intercept. So the x-intercept is what I get when I plug 0 in for y. Y-intercept is what I get when I plug 0 in for x. So if I plug 0 in for y, I'm really just covering that one up. I got 6,000 divided by 5. That's 1,200. And then if I want the y-intercept, I'm going to plug 0 in for x. So 6,000 divided by 3 is 2,000. So my y-intercept, I need to go to 2,000. So I'm going to say, this is 2,000. We'll cut it in half and say that's 1,000. So I do kind of the same thing this way. Here's 1,000. Here's about 2,000. You can scale however you want. It's not a huge deal, but just a look at the graph. And then if I connect those two, well, 2,000, 0, 2,000, and then 1,200 would be somewhere in here. And should I do a solid or a dashed line? Dashed, yeah, because it's got to be greater than. Basically anything up there would work. So any of those would be solutions for how many tickets we need to sell to make $6,000. Then for the slope, well, I do have 2 coordinates. So I could use those 2 coordinates to find the slope, or I could look at the graph and say from one point to the next, how far down did I go and how far over did I go? And if I have a graph, I'd rather use the graph. So to get from the first intercept to the other intercept, I had to go down 2,000, right 1,200. So my slope, I had to go down 2,000 and then right 1,200. So if I do reducing of that, so I knock off the zeros. Negative, let's see, 4 goes into that, so negative 5/3 be the slope. And this point slope form. So yesterday we did standard form, and we did slope intercept form. There is a point slope form, and the point slope form is great if you know the slope and at least one point. Slope intercept was great if you knew the slope and the y-intercept. Now on this one, we do know the y-intercept and the slope. So slope intercept form would be easy on this one also. But point slope form, and I put on the board up there too, in case you forget, it's in green on the right. But the point slope form is going to be y minus the y coordinate of one of the points equals the slope times x minus x1. Okay, so on this one, we do have the slope, and we do have 2 points we can plug in. So m is the slope, and then x1, y1 is just the coordinates of one of the points. So I can pick one of the points. So we can pick the second one for now. So y minus the y coordinate, minus 2,000, is going to equal the slope negative 5/3 times x minus 0. I think if you had Mrs. Bat for Algebra 1, you did point slope, because I saw it in her worksheets last year in the resource room. She did a lot of point slope. So some Algebra 1 teachers, I know she does it a lot. I think other ones don't touch point slope, or maybe they mention it and don't do a lot of it. It's not super duper important. It's one of those things that if you take calculus someday, we use point slope a lot in calculus. Algebra 2, we can kind of take it or leave it. You can use slope intercept and you'll get by just fine. But yeah, there are a few questions on the homework on the Delta Math that does ask for it in slope intercept or in point slope form. So just remember this: plug in one of the points to answer. All right. So last thing then. Let's see. Let's get back here. 3 and 4. The only thing they've done so far, we said if it's a slope-intercept, it's easier. Well, those are in standard form. So what do we need to do first for these? Well, the first thing we need to do is transform into slope-intercept form. If we get into slope-intercept form, this will, like I said, it'll be from that point forward, it'll be a pretty straightforward problem. So on this one, the slope-intercept form is just get y by itself. So this equation, I'm going to get y by itself. So my first step, I'm going to take that 4x to the right side. So 3y is going to stay where he's at. When the 4x comes over, it's a minus 4x. So we get minus 4x plus 9. And then to get y by itself, divide everything by 3. So try that one out. So try graphing that one. And if you get real bold, try the other guy. Just be careful. And remember, there on the front side, we talked about if you multiply or divide by a negative, you have to switch your sign. So be really careful. You don't forget to switch the sign if you multiply or divide by a negative. So that's kind of a hint. You will be. So try those two out. I'll be quiet and let you try those two out.